Left the world today. Right what $200 billion could build.
$126 a barrel, the highest oil price in 4 years, because of one narrow strip of water.
20 million barrels per day, stopped. 1/5 of all global oil going nowhere.
Not just oil, fertilizer, plastics, pharmaceuticals. Everything the world makes uses something from this strait.
I am standing at Fujairah Hub, the last port before the strait. 180 ships are anchored behind me. None of them are moving.
The bypass exists on paper. 32 kilometers of mountains stand between the Persian Gulf and open ocean.
This mountain range is the only thing preventing the bypass, and it is one of the most hostile terrains on Earth.
Hajar limestone, hard, fractured, full of cavities. The same rock that forms cliffs dropping into the sea.
Panama Canal, 77 kilometers through flat jungle. This bypass, 32 kilometers through vertical mountains. Shorter, 10 times harder.
No road reaches the survey points. Every piece of equipment flown in by helicopter. The survey alone takes 2 years.
At 40 meters, the drill finds nothing. A cave system the size of a cathedral hidden inside the mountain. The mountain is hollow in places. The blast sequence must be redesigned entirely around the cave network. 3,000 seismic sensors deployed across the mountain. Every underground cavity mapped before a single blast is planned.
A freshwater lens sits inside the mountain. Breach it during construction, and the canal floods before it is finished.
3 possible routes. The southern route, 38 kilometers. The central route, the northern route.
Central route selected, 32 kilometers. Peak elevation, 650 meters. 3 lock systems required. 300 meters wide, 25 meters deep. 400 million cubic meters of rock to remove. 40 times the Panama Canal excavation.
Before one blast, 180 kilometers of access road must be carved from vertical cliffs.
The road is blasted from the cliff. Workers drill the cliff face, falls into the sea. A ledge wide enough for a truck appears. After every blast, workers clear by hand. No machine can reach these ledges yet. This is how roads begin in vertical mountains. Equipment arrives by sea. There is no other way. Every machine lifted ashore by crane onto a temporary jetty. 45-degree gradients, machines climbing ledges above the sea. One wrong move, the machine goes over the edge. 6 months, 180 kilometers of road carved from 2,000 meters of mountain, before a single ton of canal excavation begins.
10,000 workers need water, food, shelter, and medical care. 200 kilometers from the nearest city. All of it built on this site.
The nearest freshwater is 200 kilometers away. Workers build a desalination plant first. Everything else waits. The construction site needs 200 megawatts. No grid connection exists. Workers build the power station before they build the canal.
180 kilometers of mountain road complete. The construction army can now reach every point of the 32-kilometer canal route.
The blast plan for this project is 4,000 pages long. Every cubic meter has been assigned a blast number, a charge size, and a sequence.
The blast sequence is designed for 40,000 individual detonations, planned over 2 years before the first charge is placed.
Every cave filled with grout before it is blasted. An unstable void underground becomes a controlled collapse.
800 vibration sensors embedded in the mountain. Every blast monitored. Excessive ground movement, construction stops immediately.
The first blast is small. Cameras at 1,000 frames per second record how the limestone breaks. The real blasting can begin.
Fragment size matters. Too large, the excavators cannot load it. Too small, dust fills the canyon and stops work for days.
I am standing inside the canal. These walls were mountains 3 days ago. The cut is already 30 meters deep. And
ANFO, ammonium nitrate and fuel oil, the cheapest explosive that breaks the most rock, 40 tons per blast. Millisecond delay detonation. Each hole fires 17 milliseconds after the last. The rock fragments instead of shattering. Controlled, precise.
The dust from one blast could close the site for 6 hours. Water cannons suppress it in 20 minutes. Workers move in immediately.
Night shifts run continuously. The blasting stops at midnight. The excavation never does. The mountain moves by day and by night. 40 excavators in the cut simultaneously, loading 100-ton dump trucks every 90 seconds.
I am standing inside the canal. The cut is already 30 meters deep.
80 drill holes per blast face, 12 meters deep each. Workers repeat this every day. ANFO, the cheapest explosive, 40 tons per blast. Millisecond delay detonation. The rock fragments instead of shattering. Water cannons suppress it in 20 minutes. Workers move in immediately. $400 million cubic meters of rock must go somewhere. It goes into the sea. Workers are building new land, 100 meters deep. The machines at the bottom look like toys from the rim. At 120 meters, the mountain bleeds, groundwater seeping through fractured limestone. A permanent dewatering network installed in the walls. 50,000 liters per hour pumped away.
The highest peak cannot be blasted from above. It is 650 meters tall. A tunnel boring machine will drive through its base.
8 meters per day, through the hardest limestone in Arabia. The TBM boring the section that the open cut cannot reach.
Tunnel spoil removed on a conveyor behind the TBM. 3,500 tons of limestone carried out for every meter of tunnel.
Evacuated at 3 a.m.
180,000 rock bolts holding the canyon walls open against the mountain's pressure. After the rock bolts, shotcrete seals the face. The mountain converted from fractured rock to stable engineered wall.
Hormuz risk premium drops $8 per barrel. The canal saves money before it carries a single ship.
16 kilometers of open cut, halfway. 200 million cubic meters removed, 200 million still to go.
The TBM breaks through. Tunnel meets open cut. The full canal route connected for the first time.
Full depth reached in the first section, 25 meters below sea level, 300 meters wide.
Maersk signs the first transit contract while the mountain is still being demolished. $50 billion in shipping committed.
250-meter walls. Workers the size of ants against them. A canyon carved from a living mountain in 3 years.
250 meters straight down. The Panama Canal took 10 years to dig. This has taken 3.
The last major blast. The main excavation complete. 400 million cubic meters removed. Workers who have spent 3 years removing a mountain stand at its bottom and celebrate.
The blasted rock face becomes the outer form. Workers install the inner form. The canal wall poured between them.
The canal wall must resist the pressure of 25 meters of water pushing outwards. The rebar cage resists that force. Concrete poured section by section. The mountain wall becomes concrete. The raw rock hidden behind the permanent lining. The concrete is waterproof from behind. The mountain's groundwater pressing from outside. The membrane keeps it out.
The canal floor, 1 meter of concrete, smooth enough for supertankers. Workers pouring the surface that will be underwater forever.
2 kilometers of finished canal. White concrete walls, smooth floor. The mountain converted into a waterway.
Bollards, lights, markers. The canal is lining. Workers are making it navigable, turning concrete into a shipping lane. The tunnel sections lined with precast segments. The same method as metro tunnels, scaled for ships instead of trains.
The water flow calculations align with the revised depth here.
Yes, but we need to ensure the tide gates are factored into the final phase.
The lock wall holds 400,000 cubic meters of water. The rebar cage for one wall weighs 8,000 tons.
15,000 cubic meters in 60 hours. The biggest single pour of the project.
The lock gates, fabricated in South Korea, 65 meters wide, 30 meters tall, 3,000 tons each.
All right, easy now. Take it up 5 meters. Copy that, 5 meters and hold.
Watch your swing to the east.
The gate is floated in. No crane large enough exists to lift it. Winches pull it millimeter by millimeter to its seat. The hydraulic system moves 3,000 tons against full water pressure. Workers install the rams that make the impossible gate swing.
The lock fills and empties through underground culverts, not over the gate. A supertanker lock chamber fills in 12 minutes. The control building is built into the canal wall. Workers and computers managing every cubic meter of water movement.
The second lock, at the peak of the canal route, 650 meters above sea level. The wall's 45 meters tall.
Confirm speed and alignment.
Tugboats, slight correction to port. Maintain current velocity. We are clear of the sill.
The water is rising at 3 meters per minute. The lock chamber will be full in 12 minutes.
The canal needs an approach channel dredged on both sides. 15 kilometers of seabed removed to 28-meter depth. Dredge spoil dumped in a designated deep water disposal area. 50 million cubic meters of seabed material moved. The canal entrances need protection from sea swell. Workers build breakwaters from 15-ton rock armor units.
Every approach buoy positioned to centimeter accuracy. Supertanker captains will follow this buoy line.
Every canal needs a port on each end. Workers building the tug berths, fuel points, and control facilities.
The canal control tower, radar coverage from 80 kilometers. Every ship on both seas visible to the controllers.
800 cameras along 32 kilometers of canal. Every meter of the world's most strategic waterway monitored in real time.
Traffic lights for supertankers. Workers installing the signal system that manages two-way traffic in a 300-meter wide canal.
A supertanker fire in a confined canal. Workers build the response infrastructure that prevents that from becoming a catastrophe.
Workers removing the last traces of construction from the canal. The equipment that built it, leaving the waterway it built behind.
The full transit test. A vessel through all 3 locks. 650 meters of elevation change.
8,000 workers, 30 nationalities, 6 years, 400 million cubic meters of mountain.
A canal where none existed. 32 kilometers, 3 lock systems, 400 million cubic meters removed.
The world's most strategic canal, complete.
Look at the size of that thing.
Yeah, it's incredible out here.
This was just a conceptual idea we brought to life. Thanks for watching.